Welcome to The Explainer. Today, we're diving deep into Cisco's Application-Centric Infrastructure, or ACI. We're going to break down the fundamental hardware and the topology that makes this whole data center solution tick.
So what's the big deal with ACI? What makes it so different? Well, it all starts right here with this spine leaf topology. You can pretty much forget those old complex three-tier network designs. ACI simplifies everything into just 2 layers. Now that might sound like a small change, but believe me, it is an absolute game changer for speed and for how easily you can scale your network.
To really wrap our heads around this, we're going to take it step by step. First, we'll lay the groundwork and understand the ACI fabric itself. Then, we'll get to know the main players, the spines, the leafs, and of course, the APIC. After that, we'll actually follow the data to see how it zips across the network. We'll also check out the different ways you can deploy ACI. And finally, we'll get our hands dirty, so to speak, with the powerful hardware that makes it all possible.
All right, let's start with the absolute core concept of the ACI fabric. You have to understand this isn't just a random collection of switches. No, this is a fully integrated system, designed from the ground up for what modern applications really need. This is really where the magic begins. ACI follows some very simple but incredibly powerful rules. Rule 1. Every single leaf switch connects to every single spine switch. This creates a super fast direct path for your data. But here's the crucial part. Leaf switches never talk to each other directly, and spines only talk to leafs. And all your endpoints, we're talking servers, firewalls, routers, you name it, they all plug into the leaf switches. This simple design has a massive impact on performance, as you're about to see. So what's the payoff for designing things this way? Well, it's huge. Let's say you need more bandwidth. You just add another spine. It's kind of like adding another lane to a highway. Need to connect more servers? No problem. You just add another leaf switch. It's like adding another on-ramp. And maybe the best part of all, no matter where your data needs to go, it's always just 2 hops away. From one leaf, up to a spine, and right back down to another leaf. What does that mean for you? It means no more traffic jams and just super predictable, lightning-fast performance for all your applications.
Okay, so let's dig into the key components and see how this all comes together to form a cohesive system. We've got the physical switches, sure, but we also have the intelligence that's controlling the whole show.
The roles here are crystal clear, really simple. The spine switches, they are the super fast backbone of the network. You can think of them as this massive data highway. The leaf switches, then, are all the on-ramps and off-ramps, where all your servers and other devices actually connect to that highway. All right, now it's time to talk about the conductor of this whole orchestra, the APIC. This is the central brain that manages absolutely everything. But here is a super important point that a lot of people get wrong. The APIC is the policy controller. It's not a traffic cop. It tells the switches what to do based on policy, but it never, ever gets in the way of your data. Your traffic flows directly between the switches, and that is exactly why ACI is so blazing fast. And check this out. This shows something really smart about the ACI design. The APIC, the brain of the entire system, it plugs into the leaf switches just like any other server would. It doesn't need any kind of special connection or special treatment. It manages the entire network from the edge, which is a really elegant and efficient way to build a network. Now, because the APIC is so critical for managing the fabric, you can bet it's designed with layers of redundancy. You have to make sure the fabric is always manageable, right? So, the APIC is protected on 2 key levels. First at the physical interface, and second at the cluster level. So, how do we make sure that APIC is always there for us? Well, first, at the physical level, each APIC actually has 2 network connections that are bonded together. A good way to think about it is like having 2 ropes tying a boat to a dock. If one rope breaks, hey, the other one is still there. In this case, the APIC connects to 2 totally different leaf switches. So if a cable gets yanked out, or even if an entire switch fails, the APIC stays online and in control. Okay, that's physical redundancy. But what about the data inside the APIC? ACI protects that too, using a clever technique called sharding. Imagine you have a giant jigsaw puzzle. Instead of keeping all the pieces in one box, you split them into 3 different boxes, and you make a copy of each piece for each box. That's pretty much what sharding does. It breaks the configuration database into pieces, or shards, and makes 3 copies of each piece, spreading them across the APIC cluster. So even if you lose an entire APIC appliance, you don't lose a single piece of your puzzle. The network just keeps on humming without a hitch. So, we've got the physical topology, we've got the management brain, but how does traffic actually get from, say, server A to server B across this fabric? This is where the real magic of the underlay and overlay comes into play. Okay,
This is where things get really cool. To understand how data moves, you first have to know about something called a tunnel endpoint, or TEP. The best way to think about a TEP is like a private IP address for each and every switch. It's not an address the outside world can see. It's just for the switches to talk to each other. This creates a sort of secret internal network that forms the very foundation of the ACI fabric.
And here's the best part, you don't have to do a thing to set up this internal network. The switches just automatically share their private TP addresses with each other using a protocol called ISIS. It's like they're all just exchanging business cards. In a matter of seconds, every switch knows exactly how to reach every other switch. This forms what we call the underlay, which is basically the physical road system of our network.
So, if the underlay is the road system, what in the world is the overlay? Well, think of it like this. When one of your servers sends some data, the first leaf switch it hits acts like a post office. It takes your data, which is like a letter, and it puts it inside a special envelope called a VXLAN packet. On the outside of that envelope, it writes the private addresses, those TEP addresses, of the sending switch and the receiving switch. Then it just sends the envelope out onto the highway. The other switches, they don't even need to know what's inside. They just look at the address on the envelope and send it on its way. This is how ACI creates a virtual network on top of the physical one, and it's incredibly powerful.
But what happens if a leaf switch gets a packet for a server it's never heard of before? Does it panic? Nope, it just asks the spines. The spines act as this all-knowing Council of Oracles. And I'm not kidding, that's what the protocol is called, the Council of Oracles Protocol, or COOP. The spines keep a master directory of where every single server lives in the network. So the leaf switch gets an instant answer and the data is on its way. It's super efficient and means the network never gets lost.
Now, ACI is definitely not a one-size-fits-all solution. Its architecture is incredibly flexible. So let's take a quick look at the different ways it can be deployed to meet all kinds of business and technical needs.
This slide just shows you how amazingly flexible ACI can be. You can build a massive, multi-tiered network for a giant data center. You can stretch a single fabric across multiple buildings with something called multipod. You can even extend it all the way to a tiny branch office with a remote leaf. There's even a fully virtual version called vPod. And for the ultimate in scale and disaster recovery, multi-site lets you connect and manage data centers that are hundreds or thousands of miles apart. The point is, ACI can really be tailored to fit almost any need you can imagine.
And finally, let's look at the powerful hardware that makes all of this possible. The entire ACI fabric is built on the Cisco Nexus 9000 series of switches, which are purpose-built for exactly this kind of environment.
All right, let's talk about the hardware that powers this beast. At the very heart of the biggest ACI fabrics is the Nexus 9500. This thing is an absolute monster. It's a modular switch, which means you can build it out as big as you need it to be. These are the engines you're going to find in the spine layer, pumping out mind-boggling amounts of bandwidth. I mean, we are talking up to 400 gigabits per second on a single port. This is what keeps all that data flowing without a single bottleneck.
And when you look inside, it's just a marvel of redundant engineering. You've got redundant supervisors, redundant system controllers, N+1 or N+N power supplies, hot swappable fan trays. Everything, and I mean everything, is designed for maximum uptime, which is absolutely essential for the core of your data center.
But of course, not everyone needs a massive modular switch like that, and that's where the Nexus 9300 series comes in. These are smaller, fixed configuration switches that are just perfect for the leaf layer. These are your top-of-rack switches where you plug in all your servers. They come in all sorts of shapes and sizes to fit your needs. And you know, in smaller ACI deployments, some of the more powerful 9300s can even step up and play the role of a spine switch, which gives you even more flexibility in your design.
So let's just put it all together. ACI combines this simple, incredibly scalable physical design with a smart controller and a virtual overlay network. And what's the result? You get a data center that's not just fast, but also incredibly agile and automated. And that leads to a really big question for everyone in this industry. When the network can practically build itself based on what your applications need, what does it mean to be a network engineer anymore? It's a huge shift from just typing commands on a CLI to defining your intent and letting automation do all the heavy lifting. It's a whole new world, and ACI is right at the forefront of it. Thanks for watching The Explainer.